Okay. In the last lesson, we talked about how to graph equations, like right at the end, that look like, oh my God, looks something like that. Okay, where we made a table of values. So we're going to practice graphing some of these. Some of these are a little more challenging. Some of these require you to do some algebra first, okay, to make it easy to do a table of values. Okay, so the first thing I want to talk about is something called literal equations. Literal equations, all the equations you guys have solved this year, the answer has been a number. Okay, it doesn't necessarily have to be that. The answer could be an expression that has letters in it. But we solve them the exact same way. So for example, if I give you the equation, x plus y equals z, and I ask you to solve for x, that means get x by itself. What must I do to this equation to get x by itself? Subtract what? Subtract what? X. I want x by itself. I want to get rid of this. So subtract y. And whatever you do to one side of the equation, you do to the other. So what does the equation look like? Well, the y's cancel there, so I'm left with x equals z minus y, which we can't combine. They're not like terms. Guess what? We're done. Did we solve for x? You guess? Is x by itself?
No. Yes.
Can I ask you something? May I ask you something? May I ask you something?
Yeah.
Why do you hurt me? We're done. This one. Yeah, it's been a long day. Equals 4s, solve for s. What must I do to get s by itself? Divide by 4. Whatever you do to one side, you do to the other. What does the equation look like? P over 4, which I can't simplify, equals s. Did I solve for s? Done. It's just you're used to seeing the answer as a number. The answer is not a number, it's an expression. This one, we want to solve for y. Well, we've got some work to do here because we've got a few things with y. Minus 6, add 6 to both sides. So what does it look like? Throw some accounts and horseshoes and hand grenades. Looks like this. What? 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 I'm looking at you. I don't know. I thought you said something. I thought you said, what's that?
No, I couldn't find what, and then you're doing this.
That's sweet. Okay. Now what?
Divide by 2.
Divide by 2. And remember, everything gets divided by 2. Well, the 2's cancel out there, and I'm left with y. So I've got y by itself. X divide 2, I can't make that any simpler. So I just leave it. However, 6 divide 2, I can make simpler. 3. Done.
If it's a fraction.
It's okay. It can be a fraction.
Oh.
Because we asked to solve for y.
Right. What's the relations?
Try to focus. Last one.
Minus
Yes, but there's something I see first, which I really don't like.
the fraction.
Yeah, I want to get rid of the fractions. How do I get rid of divide 3?
Minus 3.
And you must do that to everything. Well, 3 divide 3, they cancel each other out, so I'm left with A. Plus 3B equals what? 3C. Still don't have A by itself. We need to do one more thing. How do I get A by itself?
A is by itself.
No, it's not. There's a plus 3B with it. Minus 3B. Minus 3B. And A equals, and we can't combine these because they're not like terms, so you have to just write them as separate. I've solved for A. We're going to focus on ones like C. Okay? I just wanted to show you some different examples, but for graphing, we're going to focus on ones like C. Okay? All right, so remember, we started graphing equations that had X and Y in them last lesson, where we made a table and we picked 0, 1, and 2 for X, and we calculated Y. We plotted those points and we drew a line. That's what we're going to be doing now. But one thing you got to make sure the equation, Y is by itself. Before we do this one, let's do a little bit of an easier one. 2x plus 3. When you graph these things, first step, you want to check and make sure that Y is by itself. Is it?
Yeah.
Yeah. So that's done. That's easy. Second, we make a table of values because we need some points to plot. Always pick 0 for X. And for this one, I would also pick 1 and 2 because those are pretty easy numbers to work with. So if I plug 0 in here and calculate this side, what do I get? 2 times 0 plus 3? 3. So 2 times 0 plus 3 is 3. That means one of the points that I'm going to graph is 0, 3. But I can't draw a line yet. I need more than one point. So I'm going to plug in 1. So what is 2 times 1 plus 3? 5. So a second point is 1, 5. Just to make sure, I'm going to do one more. 2 times 2 plus 3. Yeah, you can see a pattern, 3, 5, 7. So 2, 7. Now we put those on the grid. Put those 3 points on the grid. 0, 3, 1, 5, and 2, 7. 0, 3, 1, 5, and 2, 7. If you do everything correctly, your 3 points should form a line. Okay? If this dot was over here somewhere, you made a mistake. So to finish it, draw a line through it.
How do you know if you can draw a line from there?
Well, with these type where it's just X and Y, always draw a line. Only if it's a word problem. Sometimes you draw a line, sometimes you don't. This is not a word problem. This you're just graphing a line. Whenever you see these, always a line. Okay? So this is y equals 2x plus 3. I'm going to put a second one on here, so I just want to label this one. Okay. This one. Now we get a little bit more challenging because we throw a fraction into the mix. Is y by itself? Yeah, so that's good. So we can start our table. Remember, always 0. Because 0 is easy to work with, easy to calculate with. So I plug 0 in, and it's 1 over 4 times 0 minus 2, negative 2. So one of the points on my line is 0, negative 2. Normally, I would choose 1 and 2 for x after that. But what's the problem if I choose 1? I'm going to get a fraction. And those are hard to plot. So what I want to do is what's that? You can, but they're not entirely accurate. Okay? I mean, one's like if one of the numbers is a half, that's not bad. But if you're trying to plot like 2/7, 4/5, that's hard. Okay. So I want to pick a number so that when I calculate it, I don't get a fraction. What do you think I could plug in? If I plug in 2, I get 2 over 4, no fraction. If I plug in 3, I get 3 over 4, no fraction.
4.
If I plug in 4, I get 4 divided 4, which is 1, no fraction. So plug in 4. So remember, 1 over 4 times 4 is the same as that. 1 over 4 times 4 over 1. So 4 divided 4 gives me 1, and 1 subtract 2 is negative 1. What's the next number do you think I could plug in and not get a fraction? 8. How am I getting these numbers? They're numbers that I can divide by 4 and get a whole number. So 1 over 4 times 8, or 8 over 1, minus 2. Well, this gives me 8 over 4, right? Which is, what's 8 over 4?
2.
2. Subtract 2.
0.
0. And I've got my 3 points. And if I did everything correctly, when I plot the 3 points, it should make a line that I can draw. So 0, negative 2 is down here. 4, negative 1 is here. And 8, 0 is here. They form a line. Can you, I'm curious, can you give me the definition of a weird line as opposed to just a line? When does a line become weird?
It's not straight.
Well, this is straight.
It's straight. Yeah.
This is slanted too. Why are you biased against this one? You guys are anti-line.
Hey, to be fair, I think weird is the biggest.
You're a bunch of anti-linear people.
No, you guys, in my world, being called weird is the biggest compliment you can ever give. So.
You're not weird.
Yes, I'm.
How are you not? How are you weird?
I am the weirdest person alive.
Why? Give me one reason why you're weird as compared to that one.
I'm just weird in my own way. I'm weird and I love
Well, she's weird too.
it. The biggest compliment. Being weird means you're
Different.
Means you're You're your own person.
Tell me one thing that's different about you.
I'm different. So many things.
Okay, there's so many things that telling me one thing shouldn't be hard. You don't want to tell me? It's okay if you don't want to tell me.
That makes me a little weird.
I wouldn't call that weird.
I'm different.
I have a lazy eye. Does that make me weird?
I have that now. Like,
No. So writing disability wouldn't make you weird. Like right now, I'm looking at Kendra.
can you do cardio?
No,
Then you're weird. That makes me different.
and that's okay. Okay. So yes, we get that weird line.
Yeah. What's that line? It's different amongst the rest. Yeah. It doesn't. She must feel so like. It's just like. I don't know. I don't know.
Next one. It's Y by itself.
No.
No, we got some work to do.
Oh, no.
So we got to do some algebra first, like we did at the beginning. How do I get rid of this? Plus 2x. Really? Subtract 2x. I want to get rid of the whole thing, not just the 2. Okay? Subtract 2x. So I have y, and there's still a minus 2 on the left, but on the right, there's a negative 2x. Still don't have y by itself.
Plus 2.
Plus 2. Plus 2. This is a common mistake students will make. They'll try and combine these. They're not like terms. You can't combine them.
Oh, correct.
I'll bet you one person will make that mistake. Yeah.
I have something about me somewhere.
Okay, go ahead.
I've learned, my parents taught me that I speak in first person sometimes. In my regular
You know, a lot of you do.
in my regular daily life.
Yeah, but I noticed that from a lot of you. Do you have a pencil?
And like my normal voice, like stuff.
Does this sweatshirt make me look fat?
I'll just say one word. It's like in a British. It's like in a perfectly British accent, and then I go back to it.
I know, I've heard that from students before. I don't know where, it just comes out one sentence, and then they're back to speaking with a non-English accent.
You know, basically, I didn't know I didn't know that happened.
That's weird. Okay, so we're ready to do a table. No fractions, so what do you want to pick for x?
0. Is it always? Yes. Is it always going to be 3 numbers? X.
Yes, it's always going to be 3 numbers, and I said you should always pick 0.
Okay.
Only if there's a fraction here do these ones change.
You just came back from a party only made a big.
What's a 0? Okay, so if I plug in 0, what's negative 2 times 0? Plus 2. Here's our 1 point. Negative 2 times 1. Negative 2 plus 2.
0.
We'll get 1, 0. Negative 2 times 2.
Negative 4.
Negative 4 plus 2.
What about the 2? Negative 2.
What about the what?
What happens to X? Why?
I'm replacing it with these numbers.
Yeah, right. But like, why is it times by 2?
Because negative 2 beside the x means multiply. See, there it is. There it is. Would you let me finish?
Negative 4x. The right times by 2.
Because the x disappears, it's replaced with the 2. So it's negative 2 times 2. The x is gone.
Right.
Yes.
Right.
Plot those points, draw your line. Come on. Sure.
My sister got a silver for a she graduated today. And she got they always have awards at very honey. And she got a silver Woodward Academy with the highest marks and the most volunteer. I mean, like, that's like quite a lot. They're like grade 12s.
What, they graduate early?
They did it. Graduate. We're like 2 more months. So like 3 years. When my parents they are actually and then like
I see. Okay, yeah.
like graduates.
Oh, okay. So how come you didn't go to Gray Academy or your sister didn't come here?
Because it was not a school to me.
Okay. Fair enough. Okay, let's plot these 0, 2, 1, 0. And negative 2, 0. They should form a nice line. Is that a weird line? Or is that a normal line? Would you consider that weird or normal?
I messed up.
Normal?
Oh, wait. That's not yeah, you had something down. No, I was
Oh.
I think
I was wrong. I didn't lie. You don't hear a thing from her for 25 minutes, but as soon as she detects a lie, okay. Last one of these. So this would be considered the most challenging one. Well, because we're going to get some fractions and we've got to do some algebra. Okay, so I've got some stuff with the y. I get rid of this last, get rid of what's closest to y last, so I need to get rid of 3x. But subtract 3x. Subtract 3x. Now, on the left, I've got negative 2y. On the right, I'm going to write the x term first. Negative 3x plus 6.
Where do these hits?
There's a 6 right here.
Negative and why aren't my first?
Because this is a good way to write it in for what we're gonna do different ways to graph lines next year. So I want you guys to get into the habit of writing the x first. If you wrote 6 minus 3x, I still wouldn't mark that wrong. It's still correct. But try and get into this habit for now. Okay, I still don't have y by itself. Divide into 2, which means everything. So those cancel, I'm left with y.
Wait, instead of doing like, you just put like one line under the negative 3.
Yeah, that's fine, that's fine. You can, yes, but you got to make sure to divide each one.
Okay.
All right, negative 3 divide negative 2.
Oh, brother.
Keep it the same, but yes, because it becomes positive. Exactly. Negative 3 divide negative 2, can't divide cleanly, but the two negatives become positive. And then there's still the times extra.
Plus.
6 divide negative 2. Negative 3, so there we go. Notice we have a fraction. Zero. What am I going to pick for these ones?
Six.
not 3.
Six.
What's even smaller?
Two.
2. And, I mean, 6 would work, but why not 4? If you notice a pattern, whenever there's a fraction here, pick 0, this number, and then the next multiple of 2, 4. So 0, 2, 4. If it was 3 on the bottom, I'd go 0, 3, 6. If it was 5 on the bottom, what would I do? 0,
5, 10.
right. Okay, so 3 over 2 times 0 minus 3. Negative 3. So I get 0, negative 3. 3 over 2 times 2, or 2 over 1, minus 3. What does this work out to?
6 over 2.
6 over 2, which somebody said it?
3.
3. And now I have to subtract 3.
0.
3 over 2 times 4, or 4 over 1, minus 3.
I mean, what?
12 over 2 is
12 over 2 is 6.
6 minus 3
Is 3.
is 3.
Okay, I got this. Let's see if Ralph was right or if he's still on that from he's probably going to put on the phone. Here, no, it's.
What's that, Roses? I didn't hear you.
I said. Wow.
That's better. 0, negative 3, 2, 0, and 4, 3.
Well,
Form a line. Should form a line.
Well, that one is pretty bad. Yeah, it's not pretty straight. It's okay. Sometimes it makes me a little bit. Ew, I think mine is lunch.
Oh, my nose is itchy. Okay. Last thing we're going to look at. All the lines we graphed were slanted lines. But there's 2 other types of lines. There's a line like this, which we call a horizontal line. There's a line like this, which we call a vertical line. So let's look at the horizontal line first. Give me a point on the horizontal line. Give me any point. 0, 4 is one. Tell me another one.
Oh, I understand. Positive 2.
2, 4. Give me one over here.
Positive 3.
Over here.
Exactly. Negative.
Negative 3.
6. 4. 4.
Negative 3, 4. What do you notice?
They all have 4 in it.
For the y value, right?
Yeah.
The y value is 4.
Always the same.
Like this point here is negative 1, 4. This point here is 6, 4. They're all the y's. The x values change, but the y values are always 4. So you know what we call this line?
Oh, Y line.
Y equals 4.
I love that.
Okay?
Yeah.
So a horizontal line It doesn't have an X and Y in it, just a Y. What about this one? Tell me a point on this vertical line. 0, 0 is here. 2, 0 is here.
Where are we going? -2, 0.
With 2, 0.
Where's the vertical line?
Ava, son.
Why are we not, where's an argument plus?
What?
Why are we not with 2 plus?
Because I'm looking for points on this line. Because we need to name it.
Wait,
Give me another point.
are we wait.
No, we're trying to find what its equation is.
-2, -.
-2, -4.
So the x is always the same.
Yes. The X values will be all the same. So for example, this one here is -2, 3.
So x is equal to -2.
So this line is called X equals -2. All right, so the point that I'm trying to make is that whenever you see an equation that has just a Y, it's always horizontal. If it has just an X, it's always vertical. Okay? If an equation has just a Y, no, like you notice, all the previous ones we graphed had both Y and X in. But this, if we have just a Y, it will be a horizontal line. And all we do is we just find a Y value, whatever the Y equals, and then draw a horizontal line through it. We'll see that in the next example. If an equation has just an X, it will be a vertical line. So you have to remember the difference between those two. If an equation has a Y and an X, that's when we do a table. And it'll be a slanted. We don't need to do tables for this. So for example, and I'm going to change this one. I'm going to put the Y equals -6. And I'm going to take that one out.
I think so.
Okay. So we're asked to graph these two equations. X equals -4. Is that going to be vertical or horizontal?
Vertical.
Vertical. So how do we graph it? Tell me a point anywhere on the grid where X is -4.
4, -3.
Okay, -4, -3. Now draw a vertical line through it. Done. Y equals -6. Vertical or horizontal?
Horizontal.
Horizontal.
What? Why not this way?
No, the y-axis is this way, but the actual line you graph is the opposite. It's horizontal. So give me a point where the y is -6. Well, give me a number, comma, -6.
2 and 6.
2, -6, which is there. We already said it's a horizontal line. So draw a horizontal line through that.
So
That's it.
why is the x-axis going this way and the y-axis?
It's not an axis, it's a line. It's different.
This way, the x-axis is this way, the y-line is this way, or the y-line is this way.
Because there's a difference between graphing a line and an axis.
So,
The x-axis is horizontal, but if I graph an equation that has x in it, it's vertical.
really switch.
Yes, I said that. Okay, so just, you don't have to do anything anymore. I'm going to give you an equation. You're going to tell me if it's going to be slanted, vertical, or horizontal.
Vertical, vertical.
Vertical.
No, slanted. Y-axis.
Slanted because it's got an x and y in it.
Vertical.
No.
Or horizontal.
Horizontal.
Slanted.
Slanted because it's got an x and y in it.
Fraction, does that mean it's slanted?
No, not necessarily, because I could give you this.
Okay.
What is it? It's vertical. Gotta know those. Gotta know those. Okay, good. We've gone through it.